Acceleration. When does a body possesses acceleration? In many cases, the velocity of body changes due to change either in its magnitude or direction of both. The change in the velocity of a body causes acceleration in it. Acceleration is defined as the rate of change of velocity of a body. Acceleration equals to change in velocity over time taken. Acceleration equals to final velocity minus initial velocity over time taken. A equals to Vf minus Vi over t. Taking acceleration as a initial velocity as Vi, final velocity as Vf, and t is the time interval. SI unit of acceleration is meter per second per second. Uniform acceleration. The average acceleration of a body given by equation during time t. Let the time t is divided into many smaller intervals of time. If the rate of change of velocity during all these intervals remains constant, then acceleration is also remain constant. Such a body is said to possess uniform acceleration. A body has uniform acceleration if it has equal changes in velocity in equal interval of time, however short the interval may be. Acceleration of a body is positive if its velocity increases with time. The direction of this acceleration is the same in which the body is moving without changing in its direction. Acceleration of a body is negative if velocity of the body decreases. The direction of negative acceleration is opposite to the direction in which body is moving. Negative acceleration is also called deceleration or retardation. Let us discuss the example 2.4. A car starts from rest, its velocity becomes 20 meters per second in 8 seconds. Find its acceleration. Initial velocity Vi equals to 0. Final velocity Vf equals to 20 meters per second. Time equal to 8 seconds. As A equals to Vf minus Vi over t, A is equal to 20 minus 0 over t, 8, and then A equals to 2.5 meter per second. Thus the acceleration of car is 2.5 meter per second per second. Example 2.5. Find the retardation produced when a car moving at a velocity of 30 meter per second slow down uniformly to 15 meter per second in 5 seconds. Initial velocity equals to 30 meter per second. Final velocity equals to 15 meter per second. Change in velocity equals to Vf minus Vi is equal to 15 meter per second minus 30 meter per second equals to minus 15 meter per second. Time t equals to 5 seconds. A equals to, as acceleration, A equals to change in velocity over time interval. A equals to minus 15 meter per second over 5 seconds. So A equals to 3 minus 3 meter per second per second. So retardation or deceleration of the car will be 3 meter per second. Negative sign acceleration is called as deceleration. Some important key points in topic acceleration. Acceleration of a moving object is in the direction of velocity. If its velocity is increasing, acceleration of the body is opposite to the direction of velocity if its velocity is decreasing. We will take this example to understand this concept. Graphical analysis of motion. Graph is a pictorial way of presenting information about the relation between various quantities. The quantities between which a graph is plotted are called the variables. One of the quantities is called the independent quantity, and the other quantity, the value of which varies with the independent quantity, is called dependent quantity. Distance time graph. It is useful to represent the motion of object using the graph. The term distance and displacement are used interchangeably when the motion is in straight line. Similarly, if the motion is in a straight line, then speed and velocity are also used interchangeably. In a distance time graph, time is taken along horizontal axis while vertical axis shows the distance covered by the object. The object at rest. In the graph, the distance moved by the object with time is 0. That is, the object is at rest. Thus, a horizontal line parallel to time axis on a distance time graph shows that speed of the object is 0.